Paul and I are here to talk to you about Zero Trust osquery from a cloud-native perspective, namely GitLab. Okay, so what we're going to do is talk about GitLab's journey with osquery, which really started from our strategy to deploy Zero Trust for GitLab.com. Then we'll talk about some of the challenges that we encountered and the lessons learned. So first of all, how many people here work at companies that have started to deploy Zero Trust? Okay, I'm going to say that this is probably a more enlightened crowd than the total sum of RSA attendees. Because if you look at like cloud-native companies, only 20% of cloud-native companies have even began to implement Zero Trust. 80% have not. And the 20% that have implemented usually do it after a major breach. So a good example is Google with BeyondCorp, right? After the Operation Aurora incident that happened in 2010 timeframe, that's when Google started to build, BeyondCorp. And now it's, 9 years later, and they're still building BeyondCorp. So the reason why I bring this up is because Zero Trust is definitely a process. It's a continual process. It is not a product that you can buy and put into your infrastructure and now you've got Zero Trust. That's not how that works. It's not a new idea. BeyondCorp itself had been around for many years, and even before that, there were people talking about the deperimeterization of networks. And usually, it's unfortunately, it started after a major breach. So, I think a lot of people have a lot of different ideas about what Zero Trust is. So I just want to make sure that we're at least on the same page. By industry standards, what's accepted as Zero Trust is that every user that is authenticating with every device that they might be using is all of that is taken into consideration in a risk-based way on whether they get access to that asset that they're trying to access. So it depends on the sensitivity of the data being stored or processed in the endpoint, and it depends on who the user is, and it depends on what type of device they're using to access that data. So generally, that is what's accepted to be Zero Trust. And I just want to make sure everyone's on the same page. So in GitLab's situation, what we were trying to do is we were trying to raise the bar on security for GitLab.com so that we can build better trust with customers and with users. So we thought about it in terms of three main problems that we're trying to solve. GitLab itself is 100% remote. It's a company, everyone works from home or from a cafe or wherever. There's no office to speak of, so there isn't really a formal perimeter, right, to look at. And all of GitLab.com is in Google Cloud, so the entire infrastructure is in a public cloud infrastructure. And so we thought about it in terms of we really have to do a much stronger job managing user identity and credentials and that access, right? Because we never know where people are going to be connecting from. The other thing is GitLab is all about apps, if nothing else, right? So securing those apps is a major consideration as well. And then the third thing, of course, is securing infrastructure, GitLab.com, of which there's millions of users. So then after that, we thought more about what are the different questions that we want to ask to solve different problems. And so we're looking at how systems are patched, who owns what. And the who owns what asset or resource ties into what I was saying earlier about one of the considerations of what zero trust is. We need to have an asset database and understand what we have in terms of the endpoints in the infrastructure. We also need to know what type of endpoints we have on the user side. And all of that can be augmented with osquery as well, right, as you all know. So that's really kind of the point at which we thought, we should take a look at osquery and see how we can deploy that at GitLab. So in building out the zero trust roadmap and with the strategy that we set out to build, we separated out all of the different components for GitLab itself. And so we said, okay, there is an infrastructure, GitLab.com. That's where all of the user and customer data is stored or processed or managed. That's one piece. The other piece is endpoints, right? So that includes employee laptops, user devices, all of that. That's another bucket. And then the third bucket that we want to consider for zero trust is the back-end infrastructure. What I mean by that is all of those third-party apps that GitLab uses. That can include things like Salesforce, Google Docs, whatever, G Suite. So these are all managed by some other entity on their own SaaS. And the reason why we separated it out in 3 different buckets is because ultimately that can help us build a better roadmap for how we're going to roll out zero trust over time. Remember, this is a process, and it can't be done in like a month or even a year. So what really helps is to be able to say, here are the 3 buckets that we want to consider, and for all of those buckets, here's the linear roadmap that we want to have for it. And the advantage of having a roadmap done in this way is that you can optimally work on different roadmap at the same time, right? So for example, if we're looking at orgdb, we can do that for multiple buckets at a time. And that helps you streamline your deployment process. So now that I've talked about the zero trust aspect and how that brought us to looking at osquery as part of the strategy of building out zero trust, Paul's going to talk to you about some of the challenges and lessons learned that we came across with osquery.
So to start, I really want to say that a lot of this is really based on me being not an expert in osquery in any way, stuff that we've learned through a lot of just learning and growing and breaking GitLab.com in the process. So a first little bit of this is going to be about just my experiences that hopefully my warning will prevent more outages for all of you. The second piece, I wish I'd seen Zach's talk like 6 months ago. That would have been really great, because that would have been very, very helpful for a number of things we're about to go through. So when we talk about osquery, it's all about doing those immediate hits, those immediate queries to pull various data types through osquery. And a lot of things that it doesn't do right off the hop is like there's no concept of urgency here. And there's some preconceived notions of people coming into osquery where they just, there's an assumption that this is going to just jump out at you. The data is going to be obviously apparent to you the moment you get the results of a query that something is not good. That is absolutely not the case. This is something that you need to spend a lot of time really understanding and understanding what the flavor is of what those things are and how do you build it out to get more value from it. The quality and the value of the queries you're running themselves is really that each individual result is like adding a bit of salt to a meal and just adding those individual ingredients to build something out. But really, and we've heard about it a couple times today already, is all about building out that correlation and being able to interpret what you're getting. And that's where really the value is derived, because that's how you get That's how you get a lot of the, building out the understanding of what might be an indicator of compromise is one of the biggest things, particularly in the security world. Statelessness, sure, you have the ability to use the diff engine, but, and I'll go into this in my next bit, is that has the ability to be very detrimental to some production hosts. Something that may be a front-end host that could be hitting a couple thousand users at a time, sometimes doesn't like doing a diff in those areas when you're trying to look for something like a DNS rebinding attack. The other piece is that when you combine osquery with something like chef and spec in parallel, you can actually get a lot more valuable data together to get a broader understanding of what's taking place. And the last one is when you're playing with the queries and just how you want to tune the query packs and a lot of the event tracking, this is really just rabbit holes you're going to dig into. And sometimes you just need to go and just start playing with these and making sure that you're testing these appropriately in high volume spaces, because you might just knock something over. And when you start playing with Chef, like Chef and Spec, and being able to get a lot of the orchestration together to pull this off, it's you can accomplish a lot. So, and like I was saying, so the second piece is really about just giving you the ingredients to what you have here. The query results are a great opportunity to get just the flavor of the meal and get a better understanding of just what's happening. But when you're dealing with just a point-in-time reference for an individual host, you need to find ways to bring that together to put together a complete meal and get just a solid understanding of what's happening inside your environment. And this is where you can really start fleshing out scenarios and adding weight to understand what an IOC might be. And it takes a lot of work. And if you start playing with these, and like as Zach was saying earlier, you have a really good opportunity of start tipping over in servers if your queries are running wrong, or you try to accomplish too much in one go. So inside of GitLab, we tend to do things by jumping in both feet first. We have one of our major values is to iterate on things, and one of the things that sometimes occurs is we'll jump in and just give it a go as a V1. osquery was very much one of those things for us, and really that was on me, where we assumed things like the same osquery pack would work across all of our roles in production, and that is absolutely not the case. I was about a month and a half in, I think, Kathy, when I first rolled that, and it turns out our front-end servers take a lot higher volume than you'd really expect, and some of those results just didn't play well because they run a little hot. osquery, sometimes when you were trying to do a cleanup with like RocksDB, for example, would just start tipping over hosts. And so when you're going through this process, you want to make sure that really focusing on individual role types, don't assume that your same query pack will run across many different roles. This might be common knowledge to many people, but at the same time, I can't understate just what might happen when you start using just poorly tuned, poorly created rules and queries against individual hosts. The event system, so one of the things I mentioned before was trying to look at DNS rebinding attacks. Obviously, this is a major concern that we have inside of GitLab, just because there's been a lot of opportunity for that. And as we're trying to look at high volume DNS queries, these are things that also tend to start causing major backups in RocksDB, and just have a number of challenges trying to keep up with that and do the cleanup and things. So trying to narrow that down to really focus on set roles and set understanding of what you're trying to accomplish is really important here. So the polling frequency, this is also when you want to try to get a point-in-time reference and you continuously hit hosts to try to get as much data out of them, because you want to see, because as a typical security person, you want to get as much visibility to stuff you can. And if there might be a few minutes between polling, well, you're like, well, something could happen in those few minutes. I kind of want to see what's really going on there. So you increase the polling frequency, and you start trying to collect more and more of this data to the point that this now becomes very cumbersome, particularly when you pair it with poorly designed queries. And so getting a better understanding of what you want to do and what kind of visibility you really want to see there is very important. The care and feeding, what we've also picked up is that hosts change. And in a security space here where I am at arm's length at best with a lot of our developers who are actually designing the new roles and are deploying patches and updates, is that a new Linux package could do substantial damage to a query that you're maintaining there. And making sure that you have a good understanding of how new deployments are coming out, how roles are changing, how new packages are getting updated. We saw like a change to an Engine Xbox take it down when the next time osquery ran. And so it's those kind of pieces that you want to keep a very close eye on. And then orchestration. So we've heard Puppet, we've heard Ansible. We've used Chef very heavily here. Chef has been great for being able to get query packs out, configuration changes, rolling out new versions of osquery, but that also could be a little fickle because at the same time, you can assume you just put a new package somewhere, Chef's going to roll it out, but then we've run into problems with RocksDB corruption, config overwrites, and various other unintended consequences by just allowing Chef to go do what Chef is supposed to do by rolling new like Debian packages. And so it's been a very interesting experience with osquery and all, and I'm looking forward to what we're going to be accomplishing more for our production space. But jumping a little more into the zero trust world, one of the things that we've been trying to figure out on the GitLab side of things is how do you better authenticate and authorize devices that people are using. So as Kathy alluded to, we have, we're at like 1,200 employees now, 100% remote. Right now, we don't do any device management. Everybody has their own device. We do a lot of security measures on our endpoints inside of our environment, but the individual endpoints that people are using have no centralized management. And we need to get to a point of being able to do some type of authorization to not only validate who that person is, but that their device is properly configured so that they should be allowed to access higher levels of data, such as like personal data, health data, vulnerability management data. And so we've been playing with the idea of using osquery on the endpoints to do that kind of authorization. You can actually do it on the fly. And so if we're looking at a scenario where we have someone who's going to try to log into a long-running host inside of our production space that might hold on to like audit log data, or it might have, it might be like a back-end Git repo. So we need to check first who they are. So that's authentication. That's a pretty easy process, especially like we've been rolling out Okta, so now you have 2FA that's even tied into that. The next thing is validating where they're connecting from. So that's the next big piece, is that I've managed to put a proof of concept together, and I'm looking to actually expand on it inside of GitLab for a service to actually phone back to the device that's been connecting from, to actually start looking at the type of configurations that are running on there. Now, this is something that like VPN services have been doing with custom scripting to check whether there's antivirus installed, whether there's firewalls turned on, whether there's things. But now osquery can actually tell us all of these things, and it makes it substantially easier because GitLab, for example, doesn't run a VPN. And so we also have run into a number of challenges where inside of GitLab, and there's quite a bit of it if anyone's ever gone and read our handbook, because one of our other values, in addition to iteration, is transparency. And we have a number of people inside the organization and just around the community that believe strongly that, one, we don't want to make it more difficult for employees to be able to contribute open source code. Like, why should someone from the community be able to submit an MR and actively engage when an employee needs to have a number of devices and piece of software on the computer just so they can submit that same MR? But obviously, they have access to a little more data. There's a little more sensitivity there, and they also want to know that their privacy is still safe, because there's a lot of the closed-sourced endpoint piece of software that people can install on the devices that you don't totally know what's being collected, how that's being configured, and how does this change over time? Because obviously, like compliance requirements might change because new security risks might come up. We need to make sure that those endpoints are properly being able to track that kind of data. And so by being able to use osquery on an endpoint and being very transparent and open about the query packs that are being run and putting them through like a Git repo so you can actually monitor these things, you can have individual hosts like you SSH into a front-end box. When you try to SSH in, it phones back. And then osquery will give you all the data that you need to prove that that person is who they are, that the host is configured correctly where it's from. And the last one, and arguably one of the most important, is that it's part of like the usual configuration. Because it's making sure that there isn't a lot of deviation from how systems are configured. That's really important because if one day, even if the device has the right SSH keys on it, has a right UID setup, but it's now connected from Romania than from Vancouver, but then it varies from day to day, this is a major challenge. And so being able to maintain that standard understanding of what's happening, you can start firing off alerts and you can start denying access immediately from just understanding how the configuration might be changing over time. And so I'm working to build this out right now, and I'm hoping that this is something that we can turn into how we're going to be building authorization inside of GitLab.